Hello again, and welcome to the first of two lectures on the so-called conic sections. In this lecture and the following lecture, we'll talk about circles, parabolas, ellipses, and hyperbolas. Needless to say, there are lots of applications of these concepts, both in pre-calculus and especially in calculus. In calculus courses, one uses parabolas and ellipses and things like that all the time. This lecture, I'd like to focus on circles and parabolas, and then the following lecture we'll talk about ellipses and hyperbolas. And let me just add that in the final lecture of this series, I'll take a brief look at GPS devices, which will involve circles once again. So what do we mean by a conic section? Imagine the following. Imagine two cones that are hooked together at their vertices. This is often called a double-napped cone. And imagine a plane intersecting those two cones that are glued together. It can intersect in many ways. It might intersect perpendicular to the axes, and you would get a circle as the figure of intersection. Or it might intersect at a slight angle, and that'll generate an ellipse. It could intersect at much more of an angle, and you'll get a parabola. And then the hyperbola is an intersection perpendicular to the two cones like this, a vertical intersection. And then you could also get some so-called uninteresting intersections. It might cut right across the vertex, and the intersection's a point. It could intersect in a line or in a pair of lines. We won't worry about those kinds of intersections. We're going to be talking about circles, parabolas, ellipses, and hyperbolas. So what's a circle? Well, we've been dealing with circles already. Everybody's familiar with a circle. Here's the technical definition. A circle is the set of all points, the locus of points, xy, in the plane that are equidistant from a fixed point hk. That's the center of the circle. The distance between the center and any point on the circle is called r, the radius. And knowing that definition as a set of points satisfying that criteria, you have the standard form of a circle that's very familiar to us, I think. X minus h quantity squared plus y minus k squared equals r squared. And in the happy circumstance that the circle has its center at the origin, then the equation simplifies to x squared plus y squared equals r squared. A very familiar equation. Here's a picture of our circle with center hk and radius r, and the points x, y are distance r from the center. So let's play with some circles for a moment. Let's derive some equations of circles and get comfortable with this definition. Here's my first example. The point 1, 4 is on a circle, and suppose you also know the center is minus 2, minus 3. Can you find the standard form of the equation of that circle? So we're given the center, minus 2, minus 3, and we're given a single point on the circle. What's the equation of this circle? Well, one way to do it is first find the radius, which is the distance between that point and the center. And that radius would be the difference in the x values squared, so 1 minus a minus 2 quantity squared, plus 4 minus a minus 3 quantity squared, all square rooted. That'll give the radius, and that simplifies to 3 squared plus 7 squared, or 58. So the radius is the square root of 58. Not a real pleasant number, but there it is. And now we take the equation, x minus h squared plus y minus k squared equals r squared, and plug in all these characters. H, you remember, is the x-coordinate of the center, minus 2. K is the y-coordinate, minus 3. And so you have x minus a minus 2 squared plus y minus a minus 3 squared equal to the radius squared, which is square root of 58 squared. And so the square root sign disappears, and you're left with x plus 2, minus makes plus. So x plus 2 squared plus y plus 3 squared equals 58. There's your final equation of that circle. Okay, here's a picture of it. There's the center at -2, -3. The point 1, 4 is indicated on the circle, and all the other points are the same distance away from the center. So let's analyze another equation, and we'll discover that this is also a circle, but it's sure not written in the standard form. Let's look at the equation x squared minus 6x plus y squared minus 2y plus 6 equals 0.